Hello everyone and welcome back to the course. In this lesson, we will learn about blueprint interfaces, what they are and how to use them. And to better understand why we might need to use interfaces, let's quickly jump into Unreal and see an example where it's clear that direct communication and casting are not the right approach. Let's get started. And now that we're back in Unreal, let's do a quick recap from our previous lesson. In the previous lesson, we learned about direct communication and we worked on this blueprint right here, BP_activation. And what we do is we go through an array of platforms that we have right here, and then we filter them by using an actor tag. However, you'll notice that at the end of the day, even though we have different types of platforms, they all share the same parent. But what if you had more blueprints that you wanted to activate that didn't share the same parent? And that is the first example we'll take a look at. But before we do that, you'll notice that I have some new things that I've added for this lesson. So let's go ahead and click play so we can take a look. The first thing you'll notice is that we have a door here. And if I approach the door opens, and I can go inside and look at this small scene that I have here. I have some interactive lights that if I overlap them, they switch back and forth. And I even have a switch blueprint here, that little yellow cube that is connected to this light on the ceiling. So if I approach the switch, it turns off that light on the ceiling, and if I approach it again, it turns it back on. Let's go outside. Let's click on stop. Now the main point of this lesson is to learn how we can interact with different types of blueprints, so we won't spend a lot of time looking at how I build those blueprints for the lesson. So if I'm going to double click here on the interfaces folder, let's go ahead and take a look at the door blueprint here. If I go to the viewport, you'll see that we have two static meshes, one for the frame and one for the door. And all I'm doing is I'm using a timeline like we've done in examples before, and I'm using an alpha value to lerp between 0 and -90 for the yaw rotation. And I'm doing the same thing when I'm opening the door from the back. And then we have two different triggers, one for the front and one for the back. And when we overlap those triggers, we're checking a variable called active. And if this variable is true, then we're opening the door. And when we end the overlap, we again check if the variable is true, and then we close the door. So as you can see, we have a Boolean that is basically controlling whether we can interact with the blueprint. Go back to our map. The same thing for our lights. Very simple. I have a custom event called toggle light. We use a flip-flop node, and we're going from making the light visible and invisible to simulate turning the light on and off. And again, once we overlap our trigger, which is around the light, we check whether the variable active is true or not, and then we call toggle light. So yet again, this variable is controlling whether we can interact with that blueprint or not. And finally, the light switch. We are again using an overlap. We're checking whether a Boolean called active is true or not, and if it is, we have a reference to our light, which is this blueprint here, and we're simply calling the toggle light custom event. Very simple setup, and right now everything is active. But if we wanted to disable these blueprints, we can simply make the active Boolean false. Let's go ahead and do that. And now all of these blueprints are inactive. So for the next example, let's go ahead and create a new activation blueprint that is able to activate all of those blueprints when we overlap. Okay, so I'm going to go back to our regular folder here, and let's create a brand new actor blueprint. And I'm going to name this BP_generic activator. I'm going to go ahead and open it. And just like before, I'm going to add a cube and a box collision. And we're going to add an overlap event to our box. And here we're going to do something very similar like we've done in the previous lesson. However, let's go back to our map. We have a different problem here. We need to make sure that our variable that we use for a reference can accommodate all of the different blueprints that we have. And because these blueprints don't have a common parent class like our platforms here, what can we do? Well, remember that actually all of the blueprints that we create in Unreal Engine do have a common parent, and that is the actor class. That is the simplest class that we can create that we can place in the world. So every single time you create a blueprint for your game, they will all share the actor class as their parent. So in this case, if we create an actor class for our reference, we can actually select any of the blueprints that we want in our level. So let's go ahead and do just that. I'm going to create a new variable. In this case, we're going to call this actor list. We're going to go here and click on the drop down and select actor. And all the way down, we're going to select actor object reference. And we're going to make this an array. And we're also going to make this public. And let's go ahead and compile. Now, if we go back to our map, we'll notice that if we drag our generic activator, let's go ahead and do that now. We're going to put it here for our level. If we look at our actor list, click on the plus sign. If I use a picker here, I can actually select pretty much anything in our level. You can see that we don't have that cross that we saw before. So I can select our door blueprint here, or I can select our platform here. So let's go ahead and select our platform. So you can see that we have BP platform B. And all we need to do now is simply activate our platform as we did before. So if we go back to our generic activator, we can simply use the actor list and use a for each loop. Now we can connect it. Now let's go ahead and make the array element its own variable. So right click, move to variable. Then we'll drag the array element. And now if we want to activate our platform, all we need to do is to cast this actor to our platform class. So I'll drag and search for cast platform base. And now we're saying if this array element of type actor can be converted to our platform base, we're going to drag from the pin here and we'll search for EV activate. This is the exact same thing we did from our previous example, but in this case, we're simply casting to the platform base and calling the custom event EV activate. If I click on compile, we go back to our map. If I click play, and I step on our new generic activator here, let's see what happens. As expected, our platform is activated and starts moving. Let's go ahead and stop. And now what happens if we wanted to add our door? Well, we could do the same thing. Go back to our generic activator. We can grab our array element, but this time let's cast to BP underscore door. Let's go ahead and connect it. And actually, before we do that, you'll notice that now we have to cast to one class, the platform class, and the door class. So we can use a sequence node here to make sure that we cast to both types of blueprints per the array element. So let's go ahead and do that now. And now in the case of the door, if we go back to our door, recall that all we need to do is set active to true so our player can interact with our door. So if we go back to our generic activator, all we need to do is drag from BP door and search for set active. And now we'll make this true. We'll go ahead and compile and go back to our map. And let's add this door to our actor list. So click on the plus sign here and we'll use the eyedropper tool and select our door. So you can see now we have two different classes in an array, but if I click on play and I try to enter the door is locked. I cannot interact with it. But if I step on our generic activator here, our platform starts moving, and now if I approach the door opens as expected. Let's do the same thing for the lights inside. So I'm going to duplicate our generic activator. We'll put it inside the scene, like so. And in this case, instead of using these two references, I'm going to clear the array and add the 4 lights that we have here and our light switch. And this activator has all of the lights and the light switch inside this room. However, we haven't added those classes to our generic activator. So let's go ahead and do that now. And now again, for the array element, we need to cast to our BP light. And then the light has the activate boolean just as the door. So let's go ahead and do the same thing here. And finally, the light switch, again, has the exact same principle. We have an active boolean. So let's do the same thing for the light switch. We'll drag from as light switch and search for set active. And finally set this to true. We'll go ahead and compile and save. And you can see what we're doing here. We are iterating through an array of actors. And then for each individual array element, we're casting to our platform base. And if the cast succeeds, we're activating the platform. But we're also casting to the door, the light, and the switch. And every time any of these casts succeeds, we are grabbing the active boolean of that class and setting it to active. Obviously, if the first element is a platform, this cast will succeed and every other cast will fail. So for every element, we're going to obviously be doing 4 operations and 3 of those will fail. Let's go ahead and go back to our map and just make sure that things work as expected. So if I click play, again, the door is locked. So I'm going to activate our door by stepping on the platform here. Now I can open the door. And when I go in, before I step on my activator, you can see that if we approach our lights, they are inactive, including the switch. So let's go to our activator. And now that we've supposedly activated the lights, let's go back to our lights and see if we can toggle them on and off. So you can see it is working. If I go to the switch, you can see that it is working. All right, so obviously this generic activator, while it works, you can probably tell that this is probably not the most efficient way of doing things. We have 4 different casts, and every single time we want to add a new blueprint that we want to activate, we'll have to come back to the generic activator and add yet one more cast node. Very inefficient and not very good as part of your workflow. So obviously you're thinking there must be a better way to do this. And this is when interfaces come in. So for the next example, we're going to modify our generic activator and use interfaces to simplify our code. Now let's take a moment to learn about blueprint interfaces. Interfaces are a list of function definitions grouped together inside an asset. A function definition contains the function name and its inputs and outputs, but the actual code inside the function is not contained in the interface itself. The function code itself is left to the actor blueprints that implement that interface. Let's take a look at a simple example. Say you create an interface that has a function called Activate. The interface contains only the name of the function itself. Now, when one or more blueprints implement this interface, they get the function name in the form of a custom event. It is up to each individual blueprint class to add the code relevant to that function. So a door blueprint may use this function to rotate a door mesh open so the player can pass, while a light blueprint may use the same function to toggle visibility of its light. Interfaces allow us to implement similar functionality on a wide variety of blueprint classes, which makes our code simpler and more streamlined. Okay, so now that we learned about interfaces, let's go ahead and use them with our generic activator to simplify our code. And the first thing we'll do is create the actual blueprint interface. So right click in the content browser, go to Blueprints, and select Blueprint Interface. Let's name this BPI_activate, and we'll double click to open it. And you'll see that as soon as we open it, on the right hand side we have one function called new function_0. Remember, the interface is just a list of functions that each blueprint needs to implement. So we're going to right click and let's rename this to something like INActivate. Let's go ahead and compile, and that's pretty much it. We just have one function called INActivate for this interface, and now we need to implement this interface on our various blueprints. So let's go ahead and start with our door. If we click on Class Settings and you scroll down on the Details panel, you'll see that we have an Interfaces section here, and if we click Add, you'll see that we can add our blueprint interfaces. So let's go ahead and search for BPI_activate, and we'll select it, and we'll just compile. And now we need to find a way to implement our function INActivate, and this is very simple. If we go back to our door, let's make some space here at the bottom. We'll right click and search for event and then the name of the function. And you can see here we have event INActivate. If we select it, you'll see that we have a node with a special icon here. This basically means that this is an interface, and it's called event INActivate from our VPI activate interface. So every time somebody calls that function through the interface, this node will fire. And obviously all we need to do now to activate our door is to simply set active to true. So we'll do that just now. And we'll set this to true. We'll compile, and that's it. Every time this is called, we'll simply set the active boolean to true. Now we can do the same thing for the light. Click on Class Settings. Let's implement the interface. And we'll do the same thing here. And we'll drag our active boolean and set it to true. And we'll do one more for our light switch here. All right, so 3 of our blueprints have now implemented the same interface, BPI activate, and all of them are simply setting their boolean to active. Now, just like our example before, even though we have the same function from our interface, the implementation can change per blueprint. So if BPI door needed something more than simply activating or setting active to true, we can simply add whatever code we need to activate our door. In this case, it's the exact same thing, but again, the point is every single blueprint will implement the interface function and do whatever it needs for that implementation. So now if we go to our generic activator here, we can simplify it by, instead of using the sequence of cast nodes, let's go ahead and disconnect this. All we need to do now is call the interface. So we can drag from our array element here, and let's literally search for INActivate. And you can see here that we have under VPI activate, which is our interface, a message for that function. So let's go ahead and select it. And you can see that we're simply sending, and you can see the little letter icon here. We're simply sending that message to that array element and saying, hey, if you have this interface, go ahead and call the function INActivate. If I go ahead and compile, now we go back to our map. Let's see if it works. Our generic activator still has the references to our platform and our door. So if we click on play, just to test one more time, the door is locked. Let's go back to our generic activator. And let's go back to our door. And you can see that the door works. And just the same for the lights. They're not working. Let's step on our activator. And now if I overlap my lights, they seem to be working. As you can see, instead of doing a bunch of different casts, we can dramatically simplify our functionality by using interfaces. Look how simple this is. We take a generic actor and we're going to simply use the interface here. And if the actor implements the interface, the appropriate code will run. And if it doesn't implement the interface, this will fail silently and no error will be produced. So right here you see the most common use case for using interfaces, which is, again, if you have many different blueprint actors of different classes that need to implement the same type of functionality, the ideal way of doing this is by using an interface. Not only is it way easier on the long run, but it's actually more efficient and performant. And we will talk about performance later on once we do a recap of all of the communication methods. But for now, you can clearly see which method is actually more convenient. And even though interfaces take a little bit more setup, so you can see here we have to create a separate file, it really isn't that much more work once you really understand how to use them. For this next example, let's try to implement the same functionality on the player character. Now that we know how to use interfaces, it probably makes sense that any kind of interaction or activation code goes on the player itself. So let's go ahead and do just that. If we go on our content browser here, let's click on third person, blueprints, and let's open our third person character. And the first thing we'll do is let's create a box collision volume that we will use to overlap other actors that we can potentially interact with. So let's go ahead and add a box collision and let's scale it. That looks pretty good. Let's make sure that we have our box collision selected. Let's go to our collision presets and let's select overlap all. That way we'll be able to overlap all types of actors in our level. Let's click compile. Let's right click, add event, on component begin overlap. And the first thing we'll do is, for this overlap, we want to make sure that the other actor is its own variable for convenience. So right click, promote to variable. Now we have this other actor, and we don't want to try to interact with every single actor we overlap with. There is a node that allows us to check whether an actor actually implements an interface or not, which is quite handy. So let's do that now. We can simply drag from here and search for does implement interface. Go ahead and select it. And in this node, all we need to do is select the interface class. And in this case, it's going to be BPI activate. And this will return a Boolean telling us whether this actor actually implements the interface or not. So now we can use this Boolean to create a variable that will let us know if we can interact with this actor or not. So let's right click and again promote to variable. And let's name this variable can interact. So as you can see here, every time we overlap any actor in the world, we're going to check whether they have an interface, which is BPI activate, and whether that is true or false, we're going to set a Boolean called can interact, true or false. Now the next thing we can do is we can use a key, an interaction key, and check this Boolean here before we actually send that interface message. And we haven't talked about input events, but for now, all we're going to do is that we can right click and search for any key on your keyboard. So in that case, I'm going to use E. And you see under keyboard events, go all the way down and select any key you want. In my case, I'll select E, since this key is usually used in a lot of games for interaction. So all we're going to do is, once we press E on our keyboard, we want to make sure that we can interact, so we can use the Boolean here for a branch. Let's drag can interact. And if we indeed can interact, we're just going to grab our other actor and drag from other actor and look for IN activate. There you go, very simple. We're going to overlap everything in our level. If the actor that we're overlapping implements our interface, we are now allowed to press E to interact. And then just to make sure that we know which actor we're actually activating, let's just use a print string just for convenience here. And for the int string, let's do an append node like we've done before. And we'll simply say something like activated and then the name of the actor. Then we can grab the other actor here and drag it to the B pin. And you can see that now we're just going to print which actor we just activated. Let's go ahead and compile. And now if we go back to our map, we can actually remove this. So let's go ahead and remove this here and the one inside. And if we click play, you see that now when we approach the door, it is locked. But if we approach the door and press E, you see that we have on the left-hand side that we activated our BP door. Now let's try to overlap it one more time. And the door is active. Same thing for our lights. Let's approach, press E. The light rather has been activated. So if we try to overlap it again, now we can toggle the light on and off. Same thing for our switch here. Activated our switch. Oops, activated our switch. Now when we overlap the switch, the light turns on and off. Activating all our lights, and now we can do the exact same behavior. We can toggle them on and off. So as you can see, if we go back to our player character here, look how simple this code is. We just created in just a few minutes a very simple interaction system by using interfaces. All we need to do is check whether an actor has an interface, and then once this actor is confirmed to have the interface, we can use that as a Boolean in a branch and press any key we want and simply send that interface message to activate. Each individual blueprint in our game will have the responsibility to implement its own version of what activate means. It can be as simple as setting a Boolean to true, or it can be as simple as calling a custom function or doing whatever that blueprint needs to do to accomplish that functionality. One more thing it's important to notice that we actually don't even need to do this at all. Remember, if we send an interface message to an actor that does not implement the interface, this will fail silently. So you don't really even need this node here. The reason this still might be useful is if you're thinking about interactions, you may want to do more things in your code. So for example, you may want to play an open animation, right? Where your character, where it opens the door or clicks the switch. So you wouldn't want your character to play that animation if the activation failed. This is why I wanted to show you guys this node, because it becomes quite handy. Another thing you could do is not even press a key. You could simply overlap it, and if it implements the interface, automatically go ahead and send the activate function. That will be another way that you could use this. You don't have to specify a specific key. So there's a lot of flexibility here, and as you can see, by using interfaces, we can make our code simpler, way more modular, and then as we're developing our game, we can continue to add more and more blueprints that we can interact with or basically communicate with, and we don't have to modify a lot of our code to do so. One last example I'd like to show is how to use an interface function to return a value. Interface functions, just like regular functions, can take on inputs and return outputs. So for this example, let's think about our door here. And let's say that we needed to unlock the door before we could interact with it. So we could easily create a Boolean, let's call this unlock, and we can check this Boolean before we interact with the door. If unlocked is true, then obviously we can interact with the door. So let's go ahead and compile here, and let's go back to our BPI activate, and let's create a new function, and let's call this one IN unlock. And in this case, we're going to add an output, and it could be a Boolean called unlock. And now if we go to our door and we look under my blueprints tab, you'll see that we have a section called interfaces. So if we go ahead and expand that, you'll see that we actually have 2 entries for each individual function. There's one called IN unlocked, and if we double click on it, we actually get a function where we can return a Boolean. So in this case, we can just drag our unlocked variable and simply return our Boolean unlocked. Let's go ahead and compile. Notice that this is a little bit different compared to this function right here, activate. When the function doesn't have an output, you can simply do what we did before. But if it does have an output, you have to come under the interface section here, like we did here, and specify the return. Notice that we could add any code we want here as long as we return that out. So now if we go back to our third-person character, we could use that Boolean to check. So let's make some space here, and we can grab other actor, and just like before, we can drag and search for IN unlock. And as you can see, we now have a Boolean that is being returned. We can use that for a branch. And now let's go ahead and connect it. And just like before, we have the exact same code, except now we're using another interface function to make sure that we can even interact with our actor. So if we go ahead and compile, and let's make sure that our door, in this case, is locked, which means that it is false. If we go back to our third-person map and click on play, if we try to go to the door, I'm pressing E, nothing is happening. The door is not being unlocked because, of course, our Boolean is false. So if we go back to our BP door and now make this true, again, we're just imagining that somehow we got this variable set to true somehow in our game. And now we go to our map, we approach the door, press E. Now we can see that we have activated the door. We step out, and as soon as we step back in, the door is unlocked. This is a very simple example, but it showcases how to use functions that return a value with interfaces. So remember, regular functions that have inputs you can use directly in the event graph, like so, but functions that have an output, you need to come to the interfaces section here, open the function itself, and then go ahead and return that value. Now let's do a quick recap. Interfaces are a list of function definitions grouped together inside an asset. The function code itself is left to the actor blueprint that implements that interface. Interfaces allow us to implement similar functionality on a wide variety of blueprint classes, which makes our code simpler and more streamlined. If you want to practice what we learned, think of 3 examples where you would use interfaces over direct communication or casting. And that's all for this lesson. Thank you so much for watching, and I'll see you in the next one.